Very good afternoon to all. Yes, today in this session I am going to deal with the lesson squares and square roots. In the last class we have started what are squares. Yes, squares and those are nothing but perfect squares. Okay, what do you mean by a perfect square? Yes, do you remember perfect square? Perfect square is a number. Yes, or when a number is multiplied by itself, the product what we are going to get is the perfect square. I'll repeat it again. When a number is multiplied by itself, yes, the product what we are going to get is the perfect square. If 4 is multiplied by 4, then 16 what we are going to get, that 16 is called as the perfect square. Yes, if you are multiplying 6 with 6, 6 into 6 it is 36, where 36 is a perfect square. Okay. And in the last class, we have seen some properties of squares. Okay. Now, those properties, in that we have seen that the numbers which are ending with 1 and 9, the numbers which are ending with 1 and 9, its square ends with, its square ends with 1. Yes. And if the number is ending with 2 and 8, if the number is ending with 2 and 8, its square ends with 4. Yes. Then, if a number is ending with 3 and 7, if a number ends with 3 and 7, its square ends with 9. Yes. And if it is ending with 4 and 6, as of course, its square ends with 6. 4 square 16, 3 square 36, 16 and 36, these are ending with 6. 3 and 7, 3 square 9, 7 square 49, so 49 and 9 are ending with 9, where 9 and 49 are the squares of 3 and 7 respectively. Yes, 2 and 8, 2 is 4, 8 is 64, so 4 is 4, then 8, 64, its digit is, yes, that is 4. Then 1 and 9, 9 is 81, the square of 9 is 81 and 1 square is 1, so the digit place 1 is there, therefore this is the format. And if the number is ending with 5, its square ends with 5. Okay. Now let us see one more property, that is we have seen that 10 square is 100, 20 square is 400, like that when it continues. Then what is the property that is related with number of zeros? Yes, let us consider some numbers. Yes, we consider 10 square. What is 10 square? Yes, it is 10 square is 100. If you are taking 20 square, 20 square is 400. Yes, if you are taking 40 square, 40 square is 1600. Yes, if you are taking 80 square, yes, 80 square it is 6400. Is it so? See. Now, if you consider numbers like 100 square, then what is 100 square? If you are taking 700 square, then what is its answer? If you are taking 1100 square, yes, 1100 square, and what is its square? 100 square, yes, it is 10,000. Yes, then what about 700 square? Yes, it is. Yes, I'll write and then I'll say you how to get these answers. Yes, then 1100 square. See, it can be written as 1100. Yes, because how many hundreds? 100 is there here. 1100 or 1100 square. number of zeros. Yes, examples we have seen. Yes, if k is equals to 3, then 2k is equals to 2k is nothing but the number of zeros in its square. Yes, then 2k is equals to 2 into 3, so 6 zeros. Yes, when a number is containing 3 zeros, then the square of that number contains 6 zeros. Are you getting? If it is, see, 2000 square is there. How many zeros are there in this? 3 zeros are there. So k is 3. Then 2 square is 4. Yes, 2 square is 4. When a number contains 3 zeros, its square contains 6 zeros. So we need to write 6 zeros in front of the given number. Yes, 2, 4, 6. Are you getting? So the square of this number. So here it is clear that when a number contains k number of zeros, then its square contains 2k number of zeros at the end of the square number. Yes? Okay. Now, finding the square of a number. How to find the square of a number? Finding the square of a number. Before this subtopic, there are some triangular numbers and some other properties are there that I given you yesterday as well. Yes, I think you all have understood that. If you have any doubt regarding that subtopic, you can call me and ask. That is easier part. Yes, so some number patterns are there that are easy. You can do that. Okay. Finding the square of a number. This we have learned in the lesson algebraic expressions and identities. Yes. So how to find the square of a number? The square. Where are you seeing? In algebraic expressions and identities. Yes. In that, find the square of a given number. 2x plus 3y whole square. P plus q whole square. Yes, some questions were there. So now, how to find the square of a number? It is clear that when we multiply a number by itself, when a number is multiplied by itself, we are going to get the square. That is clear. But some numbers, some digits will be given 3, 4, 5, 6, up to 9, 10, or numbers like up to 20 or 30. Those may be easy. If the numbers are find the square of a number 29. Find the square of 29. Is it easy? Sometimes it is easy, okay. But how to find the square of a number? Yes, let us see. 29 square is there. Yes. Find the square of 29. How to find? This can be expanded as 20 plus 9. Can we write 20 plus 9? Yes, of course. It is 20 plus 9 whole square. See, 29 square we are finding. That is equals to 20 plus 9 square. Yes. See, in which form it is? It is in the form a plus b whole square. Yes. A plus b whole square. What is a plus b whole square? Yes, it is a square plus 2ab plus b square. Algebraic identities follows you everywhere. So keep in mind, you have to keep in mind all those identities always. Okay. It is a plus b whole square. A plus b whole square is what? A square plus 2ab plus b square. Yes. So in this identity we have to substitute a and b. Where a is 20, b is 9. Are you getting? See, you can write like this also. A is 20 and b is 9. 47 square, it can be split as it is 40 plus 7 square. Yes, it is nothing but a plus b whole square. What is a plus b whole square? Again it is a square plus 2ab plus b square. Get the answer? Then after getting this answer, see 47 square is there, then the answer should end with which digit? 7 square, it ends with 9. Yes, your answer must end with 9. If it is not ending with 9, then your answer is wrong, because the properties we have learned, the square of a number which ends with 3 and 7, that ends with 9. Yes, the number which is containing 7 at the end, its square should contain 9 at the end. And here 9 is there, then its answer should end with 1. Yes, its answer should end with 1. If you are not getting the answer, then it is wrong. If it is not ending with 1, then that is wrong. 9 square, it should end with 1. So 29 square, it must end with 1 only. So this is how finding the square of a number. So calculate all this, because I taught you all this in the lesson, algebraic expressions and identities. Okay. So now, yes, you can pause the video and then get the answers of these. So next one, we will go for the next subtopic. Now let us see some other patterns in squares. Yes, some patterns in squares. Till now we have seen if a number is ending with 1 or 6, or if it is ending with 5, then whose square it is, which number square it is. And also we have seen if a number is ending with k number of zeros, then its square should end with 2k number of zeros. Now let us see whether if a number is ending with 5, it was clear that its square ends with 5 only. Yes, 5 square is there, it is 25. It is ending with 5 only. 15 square, yes, it is ending with 5. 25 square, it is ending with 5. Now, there is one more easier trick, how to find the square of a number when it is ending with 5. Yes, it's easy to find. See, it is 5 square is 25. That's easy. 15 square, yes, let us think that still we don't know the answer. And let us find 25 square and we will take 35 square. And then 55 square, we will take 85 square. See here. The answers of these, the square of these numbers are too easy. Yes, let us see. 15 square, it is 225. Yes, 25 square is there, yes, of course it is 625. Then we will go for 35 square, it is 1225. Yes, 55 square is there, yes, it is 3025. Yes, then 85 square is there, yes, it is 7225. How to get the answer? If you are taking any other number also, that is easy. How to find the square of a number when it is ending with 5? Yes. See, 85 square, we were not knowing. It's not easy. 85 into 85 is a actual multiplication. But without actual multiplication, we can get the square of a number. Here, for the numbers which are ending with 5, it is not necessary to find its square as 80 plus 5 square. No need, it's correct only, but it's the longer process. It is longer process only for the numbers which are ending with 5. But it is easy to find the square of a number which is ending with 5. Yes, I'll say you how. See now. 5 square is there, it is 25. Yes, that's easy. 15 square is 225. How to get? See. 15 square, it can be written as, see, 15 in this 5 square is what? It is 25. Yes, of course. Here in tens place 1 is there. What is the successive number of 1? Yes, of course, it is 2. So, multiply 1 and 2 and hundreds plus 25, 30, 30, 100. Yes, it is 100 plus 25. And like that, 8 9 yes, 72. Yes, it is 85 square. 8 into 9, hundreds plus 25. So it's easy. Whichever number you consider, the successive of that number, if you are taking 105 square, see how you have to calculate the answer. It is 10 into the successive of 10. Yes, of course it is 11. 100 plus 25. It is 110 plus 110 hundreds plus 25. Are you getting? So this is another pattern in the squares. This is also considered as the property. Getting? Okay. So now let us go for the Pythagorean triplets. Yes. What is that? Pythagorean triplets. Have you heard the word Pythagorean anywhere? Yes. Pythagoras theorem was there in 7th standard. Yes, that was related to what? Triangle. Yes, that to which triangle? Right angle triangle. That's correct. So now, what are these Pythagorean triplets? Yes, Pythagorean triplets or Pythagorean numbers. Yes, Pythagorean triplets or Pythagorean numbers. This is Pythagoras. Yes, triplets. Yes, triplets. This 3. What you are saying? Trinomials, triangle, 3. Triplets. What is the meaning of this triplets? Triplets means 3 numbers. Yes. Okay. So now let us consider some numbers 3, 4, and 5. Okay. When you consider 3, 4, and 5, here you see that what is geometry part with Pythagoras theorem? Here you may think sometimes. Yes, the Pythagoras theorem was there that is related to these numbers. There also you consider numbers. Yes, that is nothing but the square on the hypotenuse is equal to the sum of the squares on the other two sides. Yes, see here. We have considered a right angle triangle. This is ABC. Yes, it is clear that AC square is equals to what? Yes, it is AB square plus BC square. Right? The square of the hypotenuse, where AC is the hypotenuse, is equal to sum of the squares from the other two sides. Yes. So now, then we have seen that if you have considered the base as 3 cm and the perpendicular line as 4 cm, then of course we got the hypotenuse as 5 cm. Isn't it? Now, see here. 3 square is what? 3 square is 9. Yes. 4 square is 16. Now I want to add these two squares. That is 3 square plus 4 square. That is equals to 9 plus 16. Yes. 3 square is 9. 4 square is 16. Where 9 plus 16 is equals to 25. So here it is clear that 6 square plus 8 square is equals to 10 square. Therefore, 6, 8 and 10 are called as what? The Pythagorean triplets. Therefore, 6, 8 and 10 are the Pythagorean triplets. These are the Pythagorean triplets. Okay. There are some other numbers. And it is clear that when you add any two squares, you must get a perfect square only. Yes. When you add the square of any two numbers, if you get the perfect square, then only those three numbers are considered as what? Pythagorean triplets. Yes. If you are taking, yes, here you will think that, yes, we can take any other numbers also. Sometimes you will think, if you take 2, 3 and 4, okay, you may say that 2, 3 or 4 are the Pythagorean triplets. Is it correct? Are these three the Pythagorean triplets? Let us see. See, 2 square is 4, 3 square is 9. Yes, the sum of these two is what? It is 13. Sum of these two is 13. That 13 is not equal to 16. Why it is not equal to 16? Because 4 square is 16. Therefore, 2, 3, 4 are not the Pythagorean triplets. These are not the Pythagorean triplets. Yes, 2 square 4, 3 square 9, 4, 9 it is 13. That 13 is not equal to square of 4. Therefore, 2, 3, 4 are not Pythagorean triplets. Yes, are you getting? So some other numbers are there. You can go through with those. Yes, this is how the Pythagorean triplets are formed. Okay. So after this, you have to write some other. You have to find some other Pythagorean triplets. So there is a method to find the Pythagorean triplets. Okay, I'll say you how to find. Yes, it's easy. There is a formula to find the Pythagorean triplets. Yes, then what is that? For any natural number m greater than 1. For any natural number m greater than 1. Yes, the number which is greater than 1. 2m square plus m square minus 1 whole square is equals to m square plus 1 whole square. Yes, for any natural number m greater than 1, 2m square plus m square minus 1 square is equals to m square plus 1 whole square is the Pythagorean or are the Pythagorean numbers, you can write. Yes, see here, where 2m, m square minus 1 and m square plus 1 are the Pythagorean numbers. These are the Pythagorean numbers. Yes. Yes, I will look up this. See, for any natural number m which is greater than 1, because 1 is a natural number, but we are considering the number which is greater than 1, 2m square plus m square minus 1 whole square is equals to m square plus 1 square is the formula. It is the formula to find the Pythagorean triplets, where 2m, m square minus 1 and m square plus 1 are the Pythagorean numbers. These three are the Pythagorean numbers. Okay, so based on this, some examples we will take. Yes, those are given in your textbook. Okay, I'll consider that example. I hope you all have understood this. This is nothing but 2m